Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us begin solving this step by step. To determine whether a carbon is oxidized or reduced, we assign oxidation states based on the rule, each CH bond contributes -1 to the carbon's oxidation state, each C to C bond contributes 0, and each CO, CBr, or C heteroatom bond contributes +1. An increase in oxidation state is equal to oxidized, a decrease is equal to reduced. Reaction A, CH3CH is equal to CH2 plus Br2, CH3CH Br CH2 Br, C12, middle carbon, CH is equal to, in propene, C12 is equal to CH, bonded to 1H1C. Double bond counts as two bonds to same C, but each bond to heteroatom HC is counted individually. Oxidation state of C12 in propene, bonds are 1H, -1, 1C, 0 from CH3, 1C, 0 from double bond partner. OS is equal to -1. In product CH3CHBr CH2Br, C12 is CHBr, bonded to 1H, -1, 1Br, +1, to C, 0. OS is equal to 0. Change -1, 0, oxidized. C14, terminal carbon, is equal to CH2 in propene, bonded to 2H, -2, 1C, double bond, 0. OS is equal to -2. In product CH2Br, bonded to 2H, -2, 1Br, +1, 1C, 0. OS is equal to -1. Change -2, -1, oxidize. Both C12 and C14 are oxidized in A. Reaction B, CH3CH is equal to CH2-I, B2H6, 2H2O2, now H-CH3CH to CH2O. Anti-Markovnikov hydroboration oxidation. C12, middle carbon, CH is equal to, in propene OS is equal to -1, as above. In product CH3CH2, C12 is now CH2 bonded to 2H, -2, to C, 0. OS is equal to -2. Change -1, -2, reduced. C14, terminal carbon, is equal to CH2 in propene OS is equal to -2, as above. In product CH2O, bonded to 2H, -2, 1O, +1, 1C, 0. OS is equal to -1. Change -2, -1, oxidize. C12 is reduced, C14 is oxidized in B. Reaction C, CH3CH2 *CH is equal to O, na BH4-CH3CH to CH2O. Starred carbon, *CH is equal to O, aldehyde carbon bonded to 1H, -1, 1O, +1, 1C, 0. OS is equal to 0. In product CH2O, bonded to 2H, -2, 1O, +1, 1C, 0. OS is equal to -1. Change 0, -1, reduced. The starred carbon is reduced in C. Reaction D, CH3CH to *CH is equal to O, Ag plus, H2O, pH8-CH3CH to CO2H. Starred carbon, *CH is equal to O, aldehyde carbon OS is equal to 0, as computed above. In product CO2H, carboxylic acid carbon bonded to 0H2O, +2, 1C, 0. OS is equal to +2. Wait, let me recount. Carboxylic acid carbon bonds to 1C, 0, 1 is equal to O, +1, 1 OH, +1. OS is equal to +2. Change 0 +2, oxidized. The starred carbon is oxidized in D. Reaction E, CH3CO, CH2CO2H, heat dash CH3COH3 plus CO2. 12-14. C12, CH2 between the two carbonyls bonded to 2H, minus 2 to C0. OS is equal to minus 2. In product CH3COH3, C12 becomes a CH3 group bonded to 3H minus 3, 1C0. OS is equal to minus 3. Change minus 2 minus 3 reduced. C14, CO2H, carboxylic acid carbon OS is equal to plus 2 as computed above for carboxylic acid carbon 2O bonds plus 2, 1C bond 0. In product CO2, carbon bonded to 2 is equal to O, plus 2 each is equal to plus 4. OS is equal to plus 4. Change plus 2 plus 4, oxidized. C12 is reduced, C14 is oxidized in E reaction F, H to C is equal to C, of C2H5 tautomerization dash H3CO C2H5. 12-14. C12 is equal to CH2 terminal bonded to 2H, minus 2, 1C, double bond, 0. OS is equal to minus 2. In product H3C, methyl bonded to 3H, minus 3, 1C, 0. OS is equal to minus 3. Change minus 2 minus 3 reduced. C14 is equal to C, of, dash, enol carbon bearing of bonded to 0H1O plus 1 to C, 0. OS is equal to plus 1. In product C is equal to O, ketone carbonyl bonded to 0H1 is equal to O plus 1 to C, 0. OS is equal to plus 1. Let me reconsider. Enol C14, double bond to C12 and single bond to O and single bond to C2H5. Bonds 1O plus 1, 1C is equal to C12, 0, 1C, C2H5, 0, no H, OS is equal to plus 1. Ketone carbonyl C14, double bond to O and single bonds to CH3 and C2H5. Bonds 1 is equal to O, plus 1 for each bond. No use oxidation state method to bonds to O is equal to plus 2, to bonds to C is equal to 0. OS is equal to plus 2. That gives oxidized. But the answer says C14 is oxidized. Wait, the answer says C14 oxidize. Let me recheck C12. Enol is equal to CH2 has OS minus 2. Product CH3 has OS minus 3, so reduced. C14, enol C, O, is equal to using the standard method, each bond to O gives plus 1, each bond to H gives minus 1, each bond to C gives 0. C14 in enol, 1 bond to O, plus 1, 1 bond to C12 via double bond, treated as 2 bonds, 0 each. 1 bond to C2H5, 0. Total plus 1. But double bond means 2 bonds. Actually, in oxidation state counting for organic, count number of bonds to more electronegative atoms minus bonds to less electronegative atoms, H. C14 in enol H to C is equal to C, or C2H5, bonded to O, X1 plus 1, C is equal to C, 2 bonds to C12 0 each, C, C2H5, 0. OS is equal to plus 1. C14 in ketone H3CO C2H5, bonded to O via double bond, 2. Bonds to O, plus 2, C, CH3, 2000, C, C2H5, 0. OS is equal to plus 2. Change plus 1 plus 2 oxidized. C12 is reduced, C14 is oxidized in F. Therefore, the correct answer is A. C12 oxidized, C14 oxidized, B. C12 reduced, C14 oxidized, C reduced, D oxidized, E. C12 reduced, C14 oxidized, F C12 reduced, C14 oxidized. Therefore, the correct matching is A matches C12 oxidized, C14 oxidized, B matches C12 reduced, C14 oxidized, C matches reduced, D matches oxidized, E matches C12 reduced, C14 oxidized, F matches C12 reduced, C14 oxidized.